Hello? Okay. Okay, everybody hear me?
Yes.
Okay. Right now people are entering, so it takes a little while for everyone to arrive. Oops. Okay, all right, still more people coming in. I'm gonna go ahead and switch to sharing my desktop so you can see, we can get ready to start talking about Java. Okay. Okay, hello. Um, Here's what we're going to do today. We're going to start, well, here's the entry for today. Uh, last Tuesday's video is up here, okay? There's a new reading assignment for next week. I'm going to talk, your reading assignment for today was from chapter 2 of the textbook, which if I bring that up, it was about variables, okay? So you're supposed to be reading, we're going to talk to you about variables. Your reading assignment for Tuesday is more about variables, but in a different book. So it's to read this section about variables in another book. It's a real important topic. It's one of the key ideas in all of programming. So there's a chapter on variables. We'll start talking about variables today. We'll be talking about what's in this chapter here in this book. And then over the weekend, what I want you to do is to read this section and this next section 1.4 also about more about variables from this other textbook. One thing about this book here, it has lots of problems built into the, as you're reading along, the book has lots of problems that ask you, problems that they ask you, questions they ask you to answer, actual problems that they ask you to do. Work on these problems. You can, you just do the problems as you're reading. They tell you right away whether you've got them right or wrong or not. It's a way for you to just make sure that you're understanding the material as you're going along. So instead of just passively reading, you actually try to do these little exercises as you go along. So there's quite a few in this book. You can see in fact, there's probably more space spent on problems than there is explaining things. So they explain an idea and then they ask you to really think about it. So this book is very, very interactive. It's also got some videos mixed in with it, but a lot of it is asking you questions about what you've been reading. Okay, so as you go along, please make sure you answer the questions, think about them a little bit. I think it'll help a lot in making sure you understand what you're reading. Okay, this book, the other book, has a few, like this section has no problems in it. The section we went over on Tuesday had some problems in it. This one actually doesn't, this section of the book doesn't have any problems actually in the book. You just read it. It's got lots of examples, but they're examples you read. You don't actually get to play with them. Okay, so what we're going to do today is start talking about variables. Okay, and then when we're done, here will be the video for what we talked about today. I'll put it up here on the course website. It'll be right here. First, does anybody have any questions? Now I think everyone should be here by now. Does anybody has any questions about what we did on Tuesday or about the course so far?
I do.
Pardon me?
I do. I have a few.
Sure. Go ahead.
I sent you an email because I was having trouble installing, well, not installing, but running my program on Dr. Java.
Mm-hmm.
And it keeps giving me an error code.
Okay. There's been a lot of people, in getting Java on the computers sometimes can be a little bit tricky. So I've been working through all the people who need help. Send me an email when class is over with. and we can meet after class and see if we can fix what's wrong with your machine.
Okay.
Okay. Yeah, because if anybody else has still got problems getting Java on your computer, send me an email after class, because I've been working with a lot of people. There's a lot of students in the class, and I've been slowly getting through all the people, making sure everyone gets Java working on their computer. But it's been taking a little while. So if you still need more help with getting Java running, send me an email right after class, and we could probably meet right after class and try to straighten out what's wrong with your machine. Okay. So certainly, if you have any kind of problems with Java, because you need to do the first programming assignment. The first assignment is due on Tuesday. So you have to do this first assignment, which is mainly to make sure you can just do a program in Java and upload it to the Brightspace. The instructions for uploading the Brightspace are here now. Here's the instructions on how to submit a homework on Brightspace. There's even Brightspace themselves have a video about how to do this. You can watch this video on how to submit a homework assignment. Okay. So I put a link to Brightspace's help pages about submitting homework assignments. It's pretty straightforward. It's pretty easy to do. So I wrote a little explanation, and then I linked to a video and here's a help page about homework assignments. I mean, the video I linked to is just this video here. I think it's this one here. Okay. So if you have questions about submitting, that's the first part. The first homework assignment is for you to get Java on your computer, create one Java program, a real simple Java program, and then submit it on Brightspace. That's the real point of the assignment, is make sure that everybody can do the basic of getting Java running and submitting something on Brightspace. So you don't really have to solve anything. It's an easy homework assignment, but it's to make sure everything's working. The hard part is getting everything working on your computer. Okay, so if you have any questions about the homework assignment and getting Java working on your computer, send me an email after class, and we can try to get it done this afternoon. Anybody else have any other question so far about the course, or about the books, or about the Java? Anybody have any other question?
Do we need a book for this class?
Yes, but the book is, as it points out in the syllabus, the book is right here. You just click, and there's the book.
Okay.
That's the book.
Okay.
And there's actually two of them. Here's the other one. Okay, so you don't need to buy them. You just read them online. So I'll give you reading assignments from the book all the time. Like, here was a reading assignment to read chapter 1 and read chapter 2 of the book. So yeah, the book is very readable on a computer. I've noticed you can read it nicely on a tablet. You can even read it on a cell phone. The book is pretty well formatted. So if you want, you can actually buy a physical copy of the book. I don't know if anybody would want to, but the book, of the two books, one of them you can buy, actually, if you wanted to. This one is for sale. I don't think this one is even printed. I don't think there's a printed version of this one. But if you've also, this one, if you wanted to, you could we're reading it online as a website. There is a PDF version of the book, which makes it nice to print it. If you wanted to print it yourself, you could print the book. I'm not sure if there's really any need to, but the book is available as a PDF that you could print if you want. Okay, so I think reading it online is probably the best approach. Okay, so yes, you definitely have to be reading these books. I'll give you daily reading assignments. It's real important to be reading them. You have to have you have to have something that explains the programming language to you. There's a lot to learn about Java programming. So the book is pretty good about explaining these things. And in class, we'll talk about what's in the book. Okay. So, but you don't have to buy anything. So you don't have to pay. Both of the people who wrote these books purposely made them available for free over the internet. So it was the choice of the people who wrote the book, which is really nice. They chose to write the books and make them available for free. There's more and more people getting to be like that. There's more and more people who are writing books and making them available for free over the internet. In fact, just show you real quick. this book here, the first one, the guy who wrote it, if you click on his name, oh, I'm sorry, no. If you click on his publisher here, these are all books he makes available for free. He wrote all these books and he makes them available for free. He writes books about programming and about statistics and big data. And he's a professor of computer science, and he works a lot with data, what people nowadays call big data. So he makes all his books available for free. Okay, and he also has books on Java and Python and data structures. Okay, so he makes all his books available for free. And then this other book we're using, if you click on their publisher, here's a list of all the books that they make available for free. They make books on Python, Java, architecture. They make a whole slew of books available for free over the internet. Okay, so there's getting to be more and more people like that who are writing books and making them available for people to use. Like here's a C++ book. Okay, so it's nice that there are people out there who are willing to write and do things and not just to make a profit. Most of these are people who are professors at universities, so they're being paid to be professors. And when they write a book, they just say, well, they're choosing to make the book available for free instead of, they tend not to make much. Professors who write books tend not to make much money from the books. You pay a lot of money for the book. The professors tend not to make much. So a lot of them have stopped even charging for the book because they didn't make much money anyway. Most of the money went to the publisher. So now some of them are just going ahead and they're writing the book and making them available for free. And this book here, that's the guy who wrote this book, his Java book is really pretty famous. It's a really, really well-respected Java book, and he makes it available for free. Okay, so please make sure you're reading the book. Follow the program, follow the reading assignments from this page here. Okay, so like, I've given you 2 chapters to read from one of the books and a couple sections to read from the other book. Okay. Other questions? Anybody else got any other questions about what we've done so far, about how the course is going so far? Okay. Don't forget, you can watch the video. If you miss something or if you want to remind yourself of something, you can always go back and watch a piece of the video. They're up on YouTube, so they're easy to find. Okay. All right. So let's go ahead and start talking about variables. Okay. Now, let me. What I'm going to do is, I need to. Let me get Dr. Java on my desktop. So I've got Java installed, like I asked you to put it in this folder on your hard drive, and I'm going to put a shortcut to Dr. Java on my desktop, so I can use Dr. Java. So I can start Dr. Java. Okay. Now I've got an empty file here. I'm going to go ahead and create a file in Dr. Java. So I want to play with variables. So I'm going to create a class called variables. Okay. And that's going to be the file that I'm going to be putting examples in. Then I need to create a main method for this.
Excuse me, I have a question about
Sure.
the class. Would you not put public in front of the class, or
I could.
is that optional?
Yeah, I sometimes I forget. You don't have to, but you can. It's later on we'll see exactly when the word public is needed and when it's not. At the beginning of the file, it's optional, but it's a good idea. You're right. Actually, it's a good idea to put the word public there.
Okay.
Now the word public here has to be there. This one's optional. This one has to be there. But it's a good idea to put this one here. So I should say public class variables. Okay. So it's kind of funny. Over time, we'll learn the rules about when things are absolutely required, like the word public here, and when they're kind of optional, like here. Okay. Java's kind of quirky about not being consistent. In some places, it'll say, oh, you can decide for yourself whether you want to put the word public there, but you have to put the word public there. It's a little bit inconsistent about the rules sometimes. Okay, so public class variables, public static void main Eventually, we'll learn what all these words mean that I'm typing here. Like right now, we're really not saying much at all about what public static void main even mean. Okay, so here's essentially a bare bones Java program. I can save this. I'll save it on my desktop. And notice that Dr. Java calls it variables because the class is named variables, so the file should also be called variables. So I'll go ahead and save that. See, now I've got my variables.java file that I can save and go back to later on. So if I quit Dr. Java, anything I do here is saved in here. I can compile this. If I compile it, it gets translated into a class file. Now here's a trick question. What happens if I run this? What's this program going to do if I run it?
Nothing.
Nothing. Yeah, because what? I haven't told it to actually do anything. What the program does is what goes inside this part here. So I've got a Java program. It compiles, but it doesn't do anything. Here's something. I can make it do something real simple. I'll make it print hello, which is what everyone's favorite example of the start. Every textbook starts off with showing you a program that just says hello. So now if I save it, now notice, remember, saving was transferring from this screen to this file. When you make changes up here, they're actually not, like if I go here and I just type some stuff. Remember, I get the star up here is reminding you that this thing here is different than what's on the hard drive, what's saved on your computer, okay? Actually, that's the saved version. This is the actual version, variables.java. What's in the screen is not been saved to what's over here in the file. And that's not good. You know, you want to make sure that every time you make a change, like for example, if I say hello there now, I want that change to be saved here. So if I click the save button, I don't see any difference here. The star goes away, but what really happened was what I typed here was sent to this file down here. So I'm keeping this file here up to date. If I make changes over here, if I were to quit Dr. Java without saving, for example, if I just quitted Dr. Java right now without saving it, this change wouldn't be in this file. It would just be lost. Yeah, it's like Word. It's just like Word and PowerPoint. You know, if you make changes up in the screen here, you have to save your work. Otherwise, the changes don't show up on the saved file. Okay. All right. So I save it. Now, if I compile it, now there's really some, oh, I made a mistake. What did I make a mistake with? Oh, I got too many parentheses at the end here. I notice I typed 2 parentheses over here. So save it, recompile it. Okay, now I can run it. Now it'll really do something. It says hello there. Okay, all right. So that's what we talked about on Tuesday. We talked about, in the first chapter of the book, talked about just getting a basic program that just prints some things out. And your homework assignment is just to print out a little picture. Remember, if you go back over here, your first homework assignment is to just print this picture, which would be 1, 2, 3, 4, 5, 6. It's 7 lines. So that means you'll need 7 of these lines here to do 7 prints. 1 line will print this. 1 line will print the next thing. Yeah. So you'll do these each as 1 line at a time. Okay. So that'll be your first homework assignment. There'll be just 7 statements that do 7 prints. Okay. Now we want to start talking about variables. So I haven't got any variables in here. So now let me switch from Java to actually typing something that would be more appropriate in a math class. So I'm just going to type some stuff, but it's really stuff that wouldn't be Java. It'd be something you might see. Actually, I'll type it down here because it's not going to be Java. You're used to seeing equations like y equals mx plus b. That's the equation of a line that's used all the time in calculus and pre-calculus. And these letters represent what we call variables. In an equation like this, there's 2 kinds of variables. The m and the b aren't really the same as the y and the x. Usually you think of m as representing a number like the slope is 3. and you'd say b is a number, the y-intercept is 5. But you don't say what y and x are. X is all the numbers on the number line. And for every number on the number line, you get a y value. And this is the equation of a line. In fact, I can even go to Google and play around with this. For example, if I go to Google, if I Google 5x plus 3, Google's happy to draw a line for me. Google's a graphing calculator. Now here I didn't use the variable x here. Now here I used numbers here. I said 5x plus 3. But the x here, it's a variable, but it represents all the numbers on the number line between between negative 14 and 14. In a programming language like Java, we don't have variables like this. Programming languages like Java, these are sometimes referred to as algebra variables. A variable like x that represents all the numbers on the x-axis. Now let's see, I can't remember if Google will like it if I write y equals 5x plus 3. Yeah, so notice that even if I type it as y equals 5x plus 3, this is just now the y-axis and this is the x-axis. And you can see that it's telling me that as I move my little mouse around, I get a different x and y coordinate on the graph. Okay, these variables are called algebra variables, y and x. Java programming language and all programming languages, they use variables more like the m and the b. The m and the b have values. The y and the x don't have values. They represent all the numbers on the x or y axis. Okay, so there is no specific value for x. It's all numbers between negative 14 and 14. There's no specific value for y. It's all the numbers here between negative 50 and 50. Okay, but m is 3 and b is 5. Actually, let's see. I did it the other way around here. I've got m is 5 and b is 3 up here, and I wrote it differently over here. Okay, so in the picture, I have m is 5 and b is 3. Okay, all right. So in Java, I want to see now. This stuff here is not Java. So I can put a little comment symbol in front of these so Java doesn't get confused by them. So by doing this, I make Java ignore them. So that's just the math-like thing. That's just to remind you that math uses variables, but it uses variables in two ways, actually. Variables that can represent numbers specifically, and then variables that are what we sometimes call these are sometimes called constants. You know, m is the number 5, b is the number 3. And these are sometimes referred to as algebra variables. X represents all the numbers on the x-axis. Okay? And y represents all the any number on the y-axis, the vertical axis. Okay. In Java, now here in Java, I'll write something real similar. I'll write m equals 5. Put a semicolon at the end, because Java always ends, every statement in Java ends with a semicolon, just like sentences end with a period. Now, Java's not going to like this. If I compiled it, it complained. In Java, before you can give a variable a value, you have to tell Java what kind of variable it is. You have to declare the variable. So I actually need to, declare m before I can use it. And you declare it by saying that m is an integer. The int, this word here, int, it's telling Java that I'm going to use a variable m, and I'm going to store numbers that are integers in it. And we'll see in a second. That means I can't store 1.5 in m. It can only store whole numbers, 1, 2, 3, 4, 5, -1, -2, -3. But I have to tell Java that I want to use this variable. Now Java is happy. See, without the declaration, Java is complaining. With the declaration, Java is happy. Now, once I declared a variable, if I want to change it, I don't need to redeclare it. In fact, it's wrong to redeclare it. Okay, now watch. Now I declared it and made it 5, and then I updated it. if I declare it again, this is where, the languages are very picky about this stuff. If I declare it again, it doesn't like it. You're not supposed to declare it 2 times. You're supposed to declare it 1 time, then you can do anything you want with it. Once you've declared it, you can do anything you want with it, but it's a mistake to declare it 2 times. Okay, it's a mistake not to declare it, and it's a mistake to declare it 2 times. Okay, all right. Now, what can I do with a variable? I can print it, for example. Okay, and then notice that I changed the variable, so I can go ahead. I'm going to go ahead and print it 2 times because I want you to see that it does change. Okay, so compile, run. Notice that first m was 5, print m, printed 5. Then I actually updated the value of m, and I printed it again, and it printed 2. Okay. Now, for example, what if I print n, or I print b? I have a variable down here called b. What if I print b? Compile, and Java says, there's no b anywhere in your program. You never told Java, notice it says, cannot find symbol variable b. Again, you can't use a variable until you've told Java that you have to declare the variable, you have to tell Java. So I can say int b equals 3. Okay, now I could compile, Java's happy, and it'll let me print b. Okay, it'll print b. In fact, I can print m and b. So I can go back here. Here I can print m. Here I can print b. Okay. You can also, now you have variables, if you really want to, you can do arithmetic with them. So I could print m plus b for whatever, maybe that's important to me. I can do arithmetic with my variables. Like you certainly hope that once you had variables, you could do math with them. So I can, 3 plus 2 is 5. So this last 5 is actually 3 plus 2. Okay. All right. So Java has variables and the rule in Java is that you have to declare them before you could use them. Oh, and let me show you some other little details. I'm going to create a new variable. I'm going to create a variable int. I'm going to call it x. Okay. And I want to print it. Now I went ahead and I did the right thing. I declared it. So I should be able to print it. And Java is going to complain because I declare. Notice that there's nothing wrong with this. The mistake is down here. What can you print? Well, you never told Java what value is in that variable. So to Java, this is the variable x might not have been initialized. It doesn't have a number in it. There's no number in x. Notice here, when I declared it, I gave it a number. So that kept Java happy. Then when I declared this one, I gave it a number. Okay. Here, I went ahead and declared a variable, which is fine, but I didn't give it a value. Now, I can do one of 2 things. I could either give it a value here. Now Java is going to be happy. I could also, if I wanted to, I could give it a value here on a separate line. Declare it on this line, give it a value on this line. Okay. Okay. Now notice this line is okay. It declares the variable. This line is okay. It gives the variable a value. This line is okay. It prints the variable. If I were to go ahead and comment out that, what's going to happen now? What do you think might happen at this point? Is this going to be okay?
No.
No.
What's wrong?
Wait, don't the double slashes mean like ignore the line?
Yes, Right, so now line 14 is gone from Java. From the point of view of Java, line 14 is not there.
Okay, well then it won't work because you didn't declare it as an integer.
Right, so now it's back to being an undeclared variable. So line 15 is wrong, and so is line 16. Line 15 and 16 are both now using a variable that's never been declared. So if I compile this, it's going to tell me that it's actually going to tell me, notice that line 15 and 16 are both mistakes now. See, both 15 is a mistake and 16 is a mistake because Java was never told about variable X. Okay, so you've got to declare variables before you could use them. Okay, so now I put back 14 into the program. 14 declares the variable, 15 gives it a value, so now it's okay to print it. If I get rid of line 15, I'm back to having a mistake. Now line 16 is a mistake because the declaration is there, but the declaration doesn't have a value. The fact that I never gave the variable value now means there's a problem with 16. Okay, right? So you have to declare a variable and you have to make sure it has a value before you can do anything with it. Okay, now what else? So far, the variables I'm showing you are all integer variables. What if you need to work with decimal?
I have a question.
Yeah, sure.
What happens if I just want to print the letter X?
You can't. Oh, well, you can. Okay, the letter X would be printed this way. You cannot print the variable X, but you can print the string X. See, but then it's a string like hello world or Bob or Jane. You're actually printing a string. And one of the things that's going to be confusing is the difference between that string, which is not the variable X, but the string X. Now, actually, watch this. Can anybody tell me, think about, what do you think this is going to print out? System.print.
It's going to print out X. It's going to print out X equals 0, basically.
Yeah, it's going to basically print out the equation X equals 0. But now, this X is what?
It's an int.
It's an integer variable. This X is what?
String.
It's part of the string. It's as if I said Bob equals, it's very subtle. This X is part of a string. It's not a variable. This X is the variable that holds the number 0. And if I compile and run this, I get my output will show a little equation, X equals 0. Okay. Now I'm not printing the variable X. You actually cannot print the variable X. You can only print its value, which is what this does. And if you want to print the variable, you have to embed it in a string. Okay. Okay. So now if I do something funny, like suppose I change the name of this to X1. So this is X1. So this is X1. And this is X1. Compile, run. Notice it's kind of messed up right now. Why is it kind of messed up? This is a source of confusion. Let me see, what's a little bit quirky and wrong about this?
Where are we looking?
Okay, I changed my variable to be called X1. So the variable is called X1. X1 is 0. I print X1. Then I wrote here X equals X1. Now down here I have the output X equals 0. What's wrong?
Well,
You didn't didn't change the string to X1.
Yeah, so is there an X in my program?
No, not
No,
anymore.
there's an x1. There's no x anymore. So when I down here I say x is 0, I should have updated the string when I updated the variable. Okay. When I changed the name of the variable, I probably should have changed the string, but notice that there's nothing in Java to force me to do that. This is where bugs come into programs. You know, this is actually a good way you can see how a bug can enter a program. Somebody changed the name of a variable, but didn't necessarily change the string that's referring to that variable. So now I've got something that's not quite right. I say that x equals 0 in the output, but there is no x in my program. There's an x1, but there's no x. Will be better now if this said x1 equals x1. Yeah. Now compile, run. You know, now my equation says that x1 is 0 because that's my variable. My variable is x1. Notice that there's nothing in Java to keep these aligned. Like I can say here, now my output says Bob equals 0, which implies that my program has something called Bob, but my program has nothing called Bob in it. Notice that there's really nothing tying the string on this side to the variable on this side, which is actually kind of a mess. You know, this is actually not a good thing. And there are ways to solve problems like this in programming languages. But right now, there's a disconnect between what's in the string and what variables over here. And I'm implying that the value of this variable is called Bob, but the variable is actually called x1. Okay. So you actually cannot print the name of a variable. You have to always print strings, but that's actually kind of a problem because then you have to make sure the string agrees with the variable. Okay. So this should look like that. Or I could go back to I'll just go back to calling the variable x. Go back and call the variable x. Okay. All right. Now, so far, my variables are only holding integers. There's, you know, we do lots of arithmetic with decimal numbers too. In Java, if you want a variable to be a decimal number, you have to use a different declaration. You use the keyword double in your declaration. So I will declare a variable y. Now y can hold decimal numbers. See, I can put a decimal point in there, and I can print out okay. So compile, run. Notice that now I'm printing out a decimal number with something with a decimal place in it. Okay. Now, here's something a little bit interesting. Suppose I say, okay, now let me go back up here. What if I try to put a decimal number in here? So what if I go up here and say 3.5? I mean, that looks okay. M's a variable. M is 3.5.
It won't work.
It won't work because you said here, our declaration says M holds ints. And in the world of programming, everything is super precise. When you say M holds ints, you can't put decimal numbers in there. Okay, so this one doesn't get, if I compile, notice I get told incompatible types. The type of the variable is int. The type of the number is double because it's a decimal number. So Java doesn't call them decimals. For bizarre historical reason, they should call them decimal numbers, but they call them doubles. You know, double what? You know, later on you'll find out what it's a double of. It's incredibly stupid that we use these bizarre names that come up for quirky historical reasons. You know, why don't we say decimal there? You know, integer numbers and you know, why don't we say integer there? You know, why do we type it int? The reason we type it int and not integer is because back in the 60s, computer memory was really expensive, and just saving the amount of memory it took between typing int and typing integer made a lot of difference. Those extra characters had to be stored in the computer and you were paying for them. It literally boiled down to you were paying for those characters and you didn't want to. So everything back in the early days, back in the 60s, was abbreviated like crazy. You see this all the time in computer programming. You see all kinds of words being abbreviated all over the place. Like the word move is often abbreviated MV, and the word list is often abbreviated LS, and integer is abbreviated ANT. Now double got spelled out for some reason. Okay, so we have these real quirky reasons for using strange words here. Like int was abbreviated just to save space. Decimal numbers are called doubles for well, I can actually show you kind of why they're called doubles. There's another kind of decimal number called float. That's another kind of decimal number. They're called floats, not decimal, because they're actually written in scientific notation with a floating decimal point. They're actually, if I wanted to, I could use scientific notation over here and have a floating decimal point. So they were called floats. These numbers hold 8 decimal points. Okay? If I try to put more decimal points in there, I get a compiler error. No, I'm sorry, I have to get rid of this one. It doesn't hold that many decimal points. Floats only hold about 8 decimal points. I have to put the letter F after here. Okay, so that's a float. And if I put more decimal points in it, it's going to complain. Oh, it didn't complain. But it won't print out that many decimal points. Okay. It won't print out that many decimal places.
Does that mean that a double only holds 1 decimal place?
No, a float holds 8 decimal places. So guess how many decimal places a double holds?
2.
No,
16.
16. Double
Oh.
of what a float holds.
Gotcha.
Yeah, it's a quirk. It's bizarre. It's, yeah, why would they name it this way? But they chose to. A float holds about 8 decimal places. So it could be like 1.2, 3, 4, 5, 6, 7, 8. And if I put any more decimal places in there, they're just ignored. And a double would hold about 16 decimal places. And if I put any more, they get ignored. So double holds double the number of decimal places that a float does. And the float needs the little letter F after it. See, if I don't put the little letter F after it, notice that I'll get a compiler error. So I need to put the little letter F at the end to say that that's a float. And let me print them out. Okay. See how they printed out? Notice that the double ended at 8. Now let me put some more decimal places after that. Okay, I put more decimal places after the W. Notice it stopped at 8. It ignored anything. See, it holds 8 decimal places. On the other hand, the double, I can probably give it, well, I can give it a lot more decimal places. And it stopped at what? This one here, it looks like. About right? No. Which one did it? No, it stopped at. Yeah. This one stopped at the 8. And this one stopped at about that second 7. Think right there. That's where they stop at. They ignore any decimal places after that. Okay, so about double, it's got the bizarre name double because it's twice as many decimal places as float. And float is called float, not decimal, because it's actually in scientific notation, so the decimal place can float around the number. So because this stuff was invented by engineers back in the 60s, they used very engineering type terminology. So they didn't use the word decimal number, they used the word float for floating point. And then when they gave the floating point number more decimal places, they called it double because they doubled the number of decimal places. So we now call it double. We don't use floats very much anymore because they're not very accurate. And they only did floats back in the 60s because they didn't have the money to do doubles yet. Computers were very expensive back then, and memory cost a huge amount of money. So to save space and memory, just like they were abbreviating int, they did their floats with only 8 decimal places. Then eventually computers became cheaper and they could double the amount of memory. And actually now there's even, there are numbers that hold more decimal places than doubles. Okay, we'll learn about them later on, but you can get, if you need more, this is quite a few decimal places. For most scientific calculations, this is not enough decimal places. This is more than enough. Okay, going from 8 decimal places to 16 decimal places was actually pretty much good enough. 8's not enough for most scientific calculations. 16 is pretty good for most scientific calculations. Okay, so we don't usually use anything. We use doubles all the time. In Java, we use doubles. We don't. Every once in a while, you see people using floats, but by far and away, most people use doubles. Okay, so if you want to have numbers with decimal places in them, you have to say either float or double. Okay, all right. Oh, Java does not work with fractions. It only works with integers and decimal numbers. There is no 3/2 in Java. So for example, if I say y equals 3.0, okay, this is going to be kind of weird. If I say y equals 3.0 divided by 2.0, which seems to be 3/2, okay, and if I print it out, it's going to print out 1.5. It will not show me 3/2. See, 1.5. There are programming languages that work with fractions. Java is not one of them. Okay, Java doesn't work with fractions. It only works with decimal numbers and integers. Now here's something really quirky. Look what got printed out. What's 3/2? There, what got printed out?
1.0.
Yeah, what should have been printed out?
1.3 repeating.
No, what that'd be no 1.5, 3/2.
Or yeah.
So 1.5. So it should have been 1.5, but it printed out 1.0. Is Java stupider than we are? No. It's that this is Java. When we do, notice I'm using integers here. I'm doing 3 and 2, not doubles here, not decimal numbers. So Java is doing what we call integer arithmetic. And what that's asking is, how many times does 2 go into 3? And the answer is, how many 2's are in 3?
1.
1. So the answer is 1. That's called integer arithmetic. And it asks, how many 2's are there in 3? How many 2's are there in 5?
2.
2. Now 5 divided by 2 is really 2.5, but that's not what this is asking. This is not asking what's 5 divided by 2. It's called integer arithmetic. It's saying how many 2's are there in 5? And the answer is, how many 2's are there in 5 is 2. There's 2 2's in 5. And one of the big problems with programming in Java is the difference between integer arithmetic and decimal arithmetic. Now I'm switching to decimal arithmetic. 5 divided by 2 is 2.5. And this will cause you grief You'll make mistakes about this. It's an unbelievably picky little aspect of programming that this division symbol has two meanings. It could mean decimal arithmetic, or it could mean here it means integer division, and here it means decimal, like your calculator. That's because here I put integers on both sides of the slash. Here I put doubles on both sides of the slash. I put decimal numbers. Your calculator pretty much only does one of these. And you don't necessarily learn about the fact that there's something called integer division, which is different than decimal division. Your calculator pretty much defaults to this one all the time. So your calculator will do this one if you ask it to. If you know how to, you can ask your calculator to do integer division. Java, and not just Java, most programming languages, they do integer division if you give them integers. They do decimal division if you give them decimal numbers. But it's the same symbol here.
What's the utility of integer division?
We'll, as the semester, I can't tell you right now. We'll do examples later on where we'll see how it's really useful. It turns out to be really useful, but in kind of quirky ways. So we'll learn how to make use of it as we go along. They wouldn't have done it this way if there wasn't a use for it, because it's confusing, but it turns out to be useful. So it's not useful for doing scientific calculations. So you never use it in a
Is it useful with like arrays?
Yes, it's useful for things like arrays. Yeah, it's going to be useful when we get to tables and arrays. It's not useful for doing scientific calculations. You never use it in a calculus class. You don't use it in an algebra class. But it's useful in programming. So programming languages have integer division and decimal division. And now what Java did was it used the same symbol for both of them. Some programming languages try to use a different symbol for them, but Java uses the same symbol. And you have to pay attention to what's on either side of the division symbol. If there's an integer on both sides, it's integer division. One thing that's a little bit quirky, what do you think this is going to do? What might be reasonable there? There's an integer on one side and a decimal on the other side. Should it do decimal division or integer division? Make a guess.
I'm guessing integer.
No, they decided that since there's one decimal there, we should do decimal division.
Ah.
Yeah, it's actually, it's completely arbitrary. But if there's one decimal number on either side of the division, then it does decimal division. And it's a rule you just have to remember. You have to remember, well, I've mentioned several times that programming is about many picky, kind of sometimes arbitrary rules. Notice that now there was a decimal number, there was an integer, but it did decimal division, 2.5. Okay? So if you have a mixture of decimal numbers and integers, it does decimal division. Okay? Okay. Here's another little quirk. If I have an int z and I set it equal to an integer, does that look okay?
No,
Why not?
there's a decimal.
There's a decimal point. Now, it actually is an integer, but there's a decimal point. Java won't let you do that. It complains. Okay? So that is an integer, but because you wrote the decimal point, Java says, no, you can't do that. You got to leave it as really an integer. Okay? All right? So that's not, you cannot do that. Okay? So so this one is not allowed. So I'll comment it out. Now, let me do something kind of similar to it. double, let's see, I'll call it z equals 3. Now, z is a double, but what's on the right-hand side? What kind of number in Java is
Integer.
this? It's an integer. Should this be allowed?
Yes.
It is allowed. Java will allow this one. It's perfectly okay with that. Even though this is a double and this is an int, what it does is it just changes it to 3.0. Okay? So it will not convert 3.0 to 3, but it will convert 3 to 3.0. These rules drive some people crazy, and they decide that they think programming is an insane thing to be doing, and programming languages are really stupid. And some people just say, well, you can make a lot of money doing programming, so you just learn to deal with all these little rules. There actually are good reasons for all these little rules. At the beginning, they look strange, and they look annoying, and they cause lots of grief. It turns out there's actually good reasons for them. But Java will not convert 3.0 to 3, but it will convert 3 to 3.0. Okay? So you just kind of get used to the fact there's a lot of rules going on here, and some of the rules can, like this one is, okay, that's fine. Double z equals 3. It's really, I'll print it. If you print z, you'll see that when it prints, see, it really is 3.0. Even though I said double z equals 3, since z is a double and all doubles have a decimal point, Java converts 3 to 3.0 for you. But it won't go the other way around. It will not convert 3.0 to 3 for you. You might think it would be reasonable if it did, but it won't. Okay? All right. Notice we've seen a lot of weird quirks here that can cause grief. The difference between integer division and decimal division, that can cause grief. The fact that, well, 3.0 is really an integer, but it won't convert it to an integer for you, but 3 is an integer, but it'll convert it to a double for you. Okay, so there's there's all these different little quirky rules. All right, now we've seen two kinds of variables, integer variables and decimal variables. There's a third kind we're going to use, string variables. So I'm going to say I have a variable s, and I can make it a string. Okay, so now the variable holds the whole string. It doesn't hold just the number, it holds this whole string. And I can print it. Okay, and now I see I'm printing hello. I'm printing the variable s, but s is a string, so s prints out the content of the string, which is hello. Okay, now let me, suppose I want to, suppose I'm for some reason I'm greeting a bunch of people who are in a meeting. So I say, hello, Bob. Maybe I get these names from some database or something. Okay. I want to do 3 greetings. Okay, so, okay, that's no big deal. I just can. Now I decide I want to change the greeting. For example, I realized, oh, I should have capitalized hello. And so I have to make a change here, and I have to make a change here, and I have to make a change here. Okay. Now this is getting it. The thing we get is like why variables can be useful. Watch what I can do here. I can have a variable string greet equal okay, and then I can say I'm going to make my code easier to work with by doing the following. Does anybody see what's better about this?
You can
These
change
two
it
things.
hello and it'll change it to all three.
Yeah, I've abstracted out the greeting. Now over here, if I wanted to change the greeting, I had to change it possibly, here 3 times, maybe more times. Here, I'm using a variable to hold something that's being reused. This is called abstraction. It's got a fancy name. The idea is that this was common to all 3 of these. If something's common, that's something what a variable is good for. So for example, now if I want to, okay, if I run this and I see, notice I have a little mistake. Notice how hello Bob, hello Alice, hello Jane are all run together. How do I fix that?
Add space.
Add space, and I could put it, where would be the right way to fix it?
In greet.
In greet, I could fix it here, here, and here, but actually the better way to fix it is to fix it once in greet and fix my bug 1 time, not fix it 3 times. So notice I could fix it either way, but the smarter thing is to fix it once in greet. Now compile, run. Okay, now have hello Bob, hello Alice, hello Jane. Then I go, oh, I still need to fix it again. I should have said capital H for hello. Compile, run. Okay, I've got, I've got my greeting is a variable, so I could make changes to it real quickly. So for example, now I want to make it hello there. So now it's real easy to change that. And now my greeting is hello there. Over here, if I want to change it, I have to type in there. Then I have to type in there. Then I have to type in there. And if I'm not careful, I make a mistake while I'm making all these changes. So this is going to be one of the great reasons for using variables. Variables help you isolate an idea. Here, the idea is the greeting. There's a greeting and then a name, a greeting and then a name, a greeting and then a name. And it'd be nice to say, well, okay, the greeting should be in a variable so that if I want to change it, I can change it in one place, and then I use it over and over again. Okay. Now, another reason for variables is to do arithmetic. If your variables are numbers, you're usually using variables so you can do formulas and equations in arithmetic. Okay, so that's an important reason for variables. Do math, arithmetic. Here's a more abstract reason for using a variable. I want to get the greeting in one place. Instead of having hello there, hello there, hello there, and having this redundancy over and over again, I want to get the greeting in one place, give it a name in a variable, and then I can say greet Bob, greet Alice, greet Jane. That's a very different use of a variable than arithmetic. Math uses arithmetic. You use variables and equations. Y equals mx plus b. That's a powerful use of variables. Use them in formulas for doing calculations. But programmers use variables in lots of ways. It isn't just to do equations and math formulas. It's my variables will hold ideas like the greeting. And once I have the greeting in a variable, it's easier to work with. This is kind of messy to take care of. I don't want to have to keep changing the greet. Every time I think of a better, my boss tells me to change the greeting, I don't want to have to keep typing it and typing it and typing it. If my boss says they want a different greeting, it's nice to just change it in one place. Okay, so we start to see how variables, in this, when we use variables this way, we think of them, we actually use the word abstraction. I've got the greeting as a concept. I've got this is a weird idea. We'll see we use it more and more as we go programming. But what I'm really doing is I'm saying the idea of the greeting is now a concept, an abstraction. And I'm going to greet a bunch of people. And then if somebody comes along and says, we want a different greeting, well, I just change it in one place because I've isolated the greeting to one place, okay? If I want to change, a real important thing is here, and this is used in what we call internationalization. If suddenly this program is going to be used in a different part of the world, I want the greeting to be in a different language. So I may have the greeting depend on what country I'm running this program in. So, and that's actually called internationalization. You have your strings as abstractions, and then they can change their value depending on what language the program is running in. And if you went over to Google, did I misspell it? Yeah, internationalization. It's actually a concept in programming. Yeah, and it's let me see if I remember. No, there's an abbreviation for internationalization. Well, let's see. Oh, localization versus internationalization. Is your program going to only run in one country, or is your program going to run in multiple countries? Oh, here it is. I-18N. Yeah, because this is an awful long word, and it begins with I, and it ends with N, and people hate to type a lot, people have abbreviated this to I-18N. Internationalization. Programmers love to abbreviate things, okay? So programmers have all kinds of funny ways to abbreviate things. So it starts with the letter I, ends with the letter N, and there's 18 letters in between. So everybody refers to internationalization as I-18N, okay? You can see it in our program. It's showing up as this. You know, here's a baby example of it. Make your greeting this. Then you could have, then if you're going to run this program in a different country, you could just change this one string to be the greeting in that language. Okay, and that's what programmers do to do internationalization. They create tables of variables that hold values for a greeting or a salutation, or different things will be, there'll be a value for each language that the program is going to be run in. So if the greet would be there would be someplace there would be a table where greet would have lots of different values depending on what language it's going to be run in. Okay, so this is an important use of variables. Variables as abstraction. Variables where you get an idea in the variable, and then that idea is isolated in the variable so you can change it easily. That's very different than doing arithmetic on variables. Okay, here the variables are convenient ways to hold numbers, and we can change the numbers and redo calculations with different numbers. Here we're using a variable to hold an idea, not a number, an idea. Here it's actually holding a string, but the string represents a greeting, so a way of saying hello to people. Okay. All right. Now, there's one other kind of variable that we're going to be using occasionally, and that other kind of variable is something called a Boolean. And a Boolean only holds either the value true or the value false. Okay, it's going to turn out to be useful to sometimes have an abstraction of the idea of true and false. Okay, so here my variable b holds true, and if I print it, if I print b, whoops, Oh, oh, I used B already. See, I had B from y equals mx plus b. Notice, you remember, you can't reuse a variable name. Here I was trying to use B for Boolean. So I'll just call it A. Okay, so print A. I don't think I used A yet. Can't reuse a variable name. Okay, and then if I run it, see it printed out true. Now, here's something a little bit tricky. That true is not a string. Notice that it's colored blue. It's actually a value in the Java language. That's not the same thing as the string true. This won't compile because that's a string and this is supposed to be a Boolean. Booleans only can be true or false. So that's not, now when you print it out, it's kind of hard to tell. How do I know that that word true was a Boolean, not a string? I can't. From the output, I can't tell. But here, I can see that it's written differently than a string. I can put the word false in there. And those are the only two values I can put in that variable. For example, if I try to put the number 1 in there, it won't take it because 1's a number. It's not a Boolean. Okay. I can't put anything in there, but I can only put two things in there, the word true or the word false. Okay. And there's specific words in the Java language. Notice that it's color coded a different way than some of the other parts are. Okay. So Boolean is either true or false. Right now, it's not clear why I would even want something like this. The idea is that, like, suppose you have customers, you're doing a program for a bar, and you may have a customer and you need to know whether it's true or false that they're over 21 or under 21. You don't care what their age is. You only care, are they over 21 or under 21? So sometimes you don't need as much information as a person's age. You only need to store true or false. They are over 21 or not. So I could have a Boolean, I'll call it over 21, okay? And then my variable remembers whether someone is over 21 or not. So true means they are over 21, false means they're not. And I don't care what their age is, so I don't need to remember a number. I only need to remember true or false. So later on, as we go through the course, we'll see that every once in a while, having a variable that remembers just true or false can be useful. So right now we have integer variables, decimal variables, two kinds of them. We won't really make much use of the float. And the decimal numbers are called double. And so we have integer variables, decimal variables, string, and Boolean. And Java actually has 8 kinds of variables, and we'll learn what the other 4 are as we go along. So far, we've learned 4 of them. Int, double, well, actually, we've learned 5 of them. Int, double, float, Boolean, and string. So we've learned 5 of them, and there's a couple more that we learned that we'll see later on, okay? All right, now we run out of time. So this was an introduction to variables. I probably, everything I think I said is in the book. Yeah, I hope the examples kind of make some of this stuff a little bit more clear. So back at the course site, make sure you have read chapter 2, which is an introduction to variables. And then for next Tuesday, read more about variables in these 2 sections. Remember, this is more about variables. And then this other section, notice that this other section is a little bit about expressions and assignment. So it's talking about these things like the multiplication and the addition. That's what we mean by expressions. Okay, so make sure you read all the stuff in the textbook. And if you have any questions at all, please write. This example we did in class, I'll put it up on the course website. So this example, this bit of code here, I'll make it available on the course website so you can look at it. You can go back and look at the video. You can go look at this example if you want. if you have questions, send me an email. If you're still having trouble with, remember, if you're still having trouble with getting Java running, send me an email after class and we can meet and try to get your computer working. Anybody have any last minute question?
Yeah, Professor.
Sure.
For the homework assignment that's due on Tuesday, you want us to take a screenshot of it and throw it inside the folder as well, right?
Yes. So in your folder will be two files, your Java file and your screenshot file.
All right, thank you.
Okay. Yeah, so there'll be two files in the folder you send to me. And you send it to me zipped. So you'll put two files in a folder, zip the folder, and then send the zip file to Brightspace. And like I said, the instructions for sending things to Brightspace are in this file here. Actually, even if you go to the homework assignment, see it says turn in a zip file. If you click on turn in, there's the explanation of how to turn it in. Okay, so if you're reading the homework assignment, right here I remind you, this is where you click on the instructions to see how to turn things in. So here's the paragraph that says how to upload things to Brightspace. So, you know, again, this homework assignment is really just practice. It's to get you to practice using Dr. Java, doing something real simple in Dr. Java, taking a screenshot, making a zip file, and uploading the zip file to Brightspace. So it's mostly just practicing these basic computer steps. Okay. Anybody else, any other question? Anybody got any question about class? Okay. 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 We've gone a little bit over. I'm going to turn off the sharing. I'm going to go ahead and end the meeting. I'll put the video up for today up on the course website. I'll put the code we did up there on. And if you have questions, please send them to me. So I'm going to go ahead and end it now. See you on Tuesday. Bye-bye.